Yes, class. I hope I'm audible. So today and tomorrow, 2 days, we'll be completing electrostatics only, electric charges and potential, both the lessons, electric charges in field and electrostatic potential and capacitance. So I'll be discussing mixed question, or if you want, we can complete first chapter today because some questions from the first chapter were left. That's why I included this in the revision classes. Apart from this, some questions I have received. Shahid's question, I have received it on the group. Someone had sent me personally also. Who was that?
Just me.
Tarif, you had sent. Okay, okay. So towards the end, I'll discuss that also. But first, let us complete with the questions. All right, some good questions were left to be discussed. Most of it we discussed. Let me share the question first. Wait. See this question. This says that a spherical conducting shell of inner radius R1 and outer radius R2. So inner radius is R1, outer radius is R2, has a charge Q. So it means two concentric circles are there. Whenever you have such types of questions, firstly, draw it yourself. Draw the figure by yourself. So this is the outer sphere. This is the inner sphere. Now, this says that this is having radius R1 and this is having radius R2. So, conducting shell of inner radius R1, outer radius R2 has a charge plus Q. So, if the charge is plus Q, see, let's say induction will be occurring. One thing that you're for sure, that induction will be occurring. So, let's say charge, let's take a charge small q, which is placed at the center. This is saying no, a charge small q is placed at the center. So if this is plus q, which is placed at the center, so due to induction, this is plus, this side will attain negative charge from it, that is minus q it will be attaining, right? This is radius R2. And due to this induction, again, it will be having positive. See, everything is setting well. Exactly, that is what is written in the questions. Plus Q has a charge Q, a charge small q is placed at the center of the shell. Now the question says, what is the surface charge density on the inner surface and the outer surface, in the inner surface and the outer surface of the shell? So this is very easy to write. See, one thing, if this has been induced, it means this is also having some charge because of this Q. So total charge will be capital Q plus small q. When we are talking about the total charge will be plus q by small q for the outer surface. So when it is saying for the inner surface, when it is saying for the inner surface, when this is saying the surface charge density for the inner surface. So look, what is the formula of surface charge density? Sigma. Charge per unit area, right? When we are talking about this shell, we'll be considering only small q, because over this shell only small q is present. Divided by 4 pi, R1 square is the area. That is for the inner surface. But the same thing when we are talking about the outer surface. Look, when this is sigma inside, when we're talking about sigma outside, what is the total charge? Total charge is plus q. This is the total. Capital Q plus small q. And what is the radius? R2. So this becomes 4 pi R2 squared. So first part is very easy. Like this, you have to solve the first part. Second part says that write the expression for the electric field at a point X, which is greater than the shell. So see, for the B part, which says that X is greater than R2. So this is exactly similar to electric field at a point X. Are you able to relate this? This is something like, let me tell you, this is something like, this is the sphere, radius of the sphere is R2. This is like, it is saying at a separation X, you have to calculate the electric field. So we have this case already. You already know the formula, electric field at a point outside. This is equal to K 1 over 4 pi epsilon naught. Charge will be the total charge. Total charge is Q plus Q. And what is the radius? Separation is X. that is x square, like this only you had to write. So it's a very easy question, but if you look at the same time, it is difficult as well. If you're not able to handle it, you'll not, you just have to draw the figure, then you will be able to figure it out. Write it down. See, this says that a charge Q, again, this is the charge Q, is distributed uniformly. Charge Q is distributed uniformly over a ring of radius R. This says that a sphere of equal radius R means both the spheres are identical. This, at least this can be confirmed that both the spheres are identical. Is constructed with its center as the primary, as the periphery of the ring, like this. It is already shown. This is the ring which is shown. And this is the sphere which is shown. You have to find out the electric flux. Electric flux is unknown and to be calculated. All right. See, one thing at least you should be sure of. When you look at these sides, OA or O dash A, can anyone tell me what exactly is OA or O dash A? I am asking about OA and O dash A. Anyone? By looking at the figure, looking at the circle or the sphere, can you figure out anything about this O point and A point, and O dash and A? Or even you can include this O dash. You can include this O dash also. But let me know what is this. These three. Anyone? OA, O dash A, O dash. No one? Austin? Austin, you're not audible. Please type. Austin, anything if you have to answer. Yes, Shahid?
Is it equatorial dipole?
It is not dipole. Dipole is not. For dipole, you have to have two equal and opposite charges. I'm just asking, what is OA? Fia, somewhat your answer was correct, Fia. Just figure it out. Somewhat your answer, half your answer was correct.
Hypotenuse, ma'am.
No. That equilateral triangle part. Very good, Shahid. Radius. Class, look. OA is the radius of this ring. O dash A is the radius of the sphere. O dash is the radius of the ring as well as the sphere. It means this is also the radius, this is also the radius, this is also the radius. Now, what Fia you were saying was exactly right, that this forms an equilateral triangle. Now clear, Fia, why this is an equilateral triangle and not a dipole?
Yes, ma'am.
All right. So that part was right. Very good, Fia, that it is equilateral triangle, and very well answered, Shahid. This is the radius. If you've understood this, if you have identified this from the figure, now your answer is, your entire question is very obvious. See, this is an equilateral triangle, right? This is an equilateral triangle. So if this is an equilateral triangle, when we talk about the angle, this angle is 30 degree. So this entire angle will become 60, this is 60. So this becomes 120 degree. Right? This entire angle is C. This is which triangle we are talking about? We are talking about O dash A. This is an equilateral triangle. So angle O dash is 60 degree. So the bigger angle, that is angle AOB, this will be 120. So I hope the geometry part is clear to all of you. Now see, what does this show? Obviously, this shows that 1/3 of portion of the ring lies in the sphere. This is 1/3 portion of it. According to the angles, you can predict. If this is 20, this is 120 degree. We'll not see it from the figure. We'll see it through the angles. If this is 60 degree, this is 120 degree. Obviously, this is showing that ring lies in 1/3 of sphere. All right. So 1/3 third portion of AO dash B of the ring. This much portions, 1/3 lies in the sphere. That's it. What would be the charge enclosed? Total charge was Q, so only 1/3 of it, that is Q by 3. What will be the flux? Flux is Q enclosed by epsilon naught, that is Q by 3 epsilon naught. This would be the answer. So answer will come in one line only, but this part was important to identify. Note it down. One very important question we'll see after this. It's a little lengthy also. You should try it by yourself. See, this says that an early model of an atom considered it to have a positively charged point nucleus of charge Ze surrounded by uniform density of negative charge up to radius r. The atom as a whole is neutral for this model. What is the electric field at a distance r from the nucleus? Means from the nucleus at a separation r, we have to find out the electric field. Look, one thing. Let's say this is the nucleus. It means all this will be the negative charges. This is what it is saying, right? One thing that it is definitely telling is that this is radius capital R. Electric field is existing, but electric field has to be calculated at a separation smaller, which is greater, right? R from the nucleus. Class, now pay attention to it because this involves a little concept of your atoms, which you have already studied in modern physics. Why are we drawing one thing? Why are we drawing it like this? Because this is early model of an atom. This is an early model of an atom. Now see, you know that the atom as a whole, this is neutral. So it means total negative charge when we are calculating. Total negative charge for that radius capital R, this has to be minus Ze, right? Let's say rho is the, let's say this rho is the negative charge density. This is the negative charge density. All right. So for this, you should have, look, Ze will be there. Plus, when we are talking about the density, that is mass by volume, this will be 4 by 3 pi capital R cube, entire volume into density, right? Volume into density for the entire mass. This is the total charge. That should be equal to 0. Why 0? Because the atom is electrically neutral as specified in the question. This is given to you in the question. Now, here this term will go, it will be negative. Let's write only rho. This will become minus 3. This will here go, it will be minus. So this will be multiplied Ze and 4 pi capital R cube will come in the denominator, correct? See, this term will be here. Here, this will go, that will become minus Ze. Then you will multiply this 3. So that becomes minus 3 Ze divided by 4 pi R cube. Now see, when you are calculating, it is not specified in the question. The question usually mentions two conditions whenever we are solving these questions. Either it gives a condition where this small r is greater than capital R, where you use the specified formula of electric field. Second condition that is specified is it is less than capital R, where you calculate the electric field. In this question, it is vague. It is just saying from the nucleus. This is clearly saying that you have to calculate it at a distance r from the nucleus. From the nucleus could be the first case, it could be the second case. So in such case, what will you do in the question if it comes in your exam? You will mention both the parts. That is, for r less than capital R, flux through the Gaussian surface when we'll be calculating. Electric field into 4 pi small r only, right? We are taking it somewhere here. So for that, the Gaussian surface, this will be 4 pi r square, correct? Now see, let's say Q is the positive nuclear charge. What will be the total charge? Total charge will be the positive nuclear charge. Positive nuclear charge plus the negative charge in the sphere that we are calculating, plus the negative charge in the sphere, plus the negative charge in the sphere, right? So how will you write it? Positive nuclear charge is what? Plus ZE, right? What is the negative charge? That is, we have already written the value 4 by 3 pi small r cube for this, right? And then is it sufficient? Can we write down the value of rho now? We have already calculated the negative value of rho. This value of rho we have calculated. We'll substitute it here. This becomes ZE plus 4 pi r cube by 3. For rho, we will write minus 3 ZE by 4 pi capital R cube. Look, automatically your negative charge density is coming. So if we take ZE common, we'll be left with 1 minus small r cube by capital R cube, because 4 pi after taking common and even being multiplied here, 4 pi directly would be cancelled. 3 would be cancelled. ZE has been taken common. 1 minus small r cube by capital R cube is only left. Now if you apply Gauss theorem, this will be equal to Q by epsilon naught. So now you equate both these equations. Electric field into 4 pi r square would be equal to, what is the charge? Charge is ZE 1 minus r cube by capital R cube divided by epsilon naught. So what is the electric field? Electric field is ZE by 4 pi epsilon naught. Let's multiply r square inside. So this will become 1 by r square minus r by r cube. Why r cube? Because r square has been cut. So this is only left. And one more thing, you have to remember that the direction E is radially outwards, which you already know, which you already mentioned, but mentioning is important. But if this is the same part, if we are writing r is greater than this r, then one thing, class, atom entirely is neutral. So charge enclosed will be 0. Flux will be 0. Electric field will be 0. Straight away you will get your answer 0. And one more case is possible, class. Less than and greater than we have discussed. What if both are equal? If both are equal, then also atom is electrically neutral. So again the charge enclosed will be 0. Flux will be 0, electric field will be 0. It's a very important question, very lengthy question, and calculations also are there. Lots of concepts are there in this question. Then I'll discuss the questions which you people have sent me on WhatsApp after this. Write it down. Yes, Shahid. One or two questions are from current electricity. One question is from current electricity. One is from capacitance that I'll discuss tomorrow only. This 31st question which you've sent, state Gauss law of electrostatics. Using it, calculate the electric field due to uniformly charged thin spherical shell at a point inside the shell, outside the shell. All right. See, this derivation we have done. You have to calculate the electric field within uniformly charged electric shell inside and outside. It's just that, let me just show you. For such types of questions, one thing you should know that when you are calculating the electric field, at a point outside, at a point inside, one step that will be fixed is E dot S cos theta, ES cos theta, not dot. ES cos theta will be there in the plan. So phi will be equal to E 4 pi r square. Till here it's fixed. Flux you know is Q by epsilon naught. So you will equate these two. That is E 4 pi r square is equal to Q by epsilon naught. Now, depending upon R, you will have different values of electric field. This will be equal to greater or equal to, so you will replace it by R. If it is R is greater than capital R, so you will only put as small r. Like this only you will keep it. Second says, two hollow concentric spheres S1, S2 enclosing charges E1 and no, enclosing charges Q and minus Q. Q and 2Q, okay, respectively. Okay, figure is drawn. S1 is there, S2 is there, 2Q is there, Q is there. You have to tell the ratio of electric field. See. This is given. This is saying this is S1, this is S2, this is Q, this is 2Q. You have to tell the ratio of electric field. See, when we are talking about flux 1, there only Q is there, so that becomes Q by epsilon naught, correct? When we are talking about flux 2, that is the outermost. That time the total charge enclosed is 2Q plus Q by epsilon naught. So this is equal to 3Q by epsilon naught. So when you'll take their ratio, flux 1 by flux 2, Q by epsilon naught into 3Q by epsilon naught. The ratio is 1 by 3. This would be the answer. Clear? Then optional question says, derive an expression for torque experienced by an electric dipole. This derivation we have done in the class. Right? That would be clear to you, I hope. An electric dipole of length 2 centimeter making an angle. Okay, angle is given, electric field is given, length is given, torque is given. That question I hope you were, I think you must be having difficulty in this part only because this is easy. Electric field is mentioned. This is how much? 10 to the power 5. Newton per coulomb is there. Angle is given as 60 degree. Length is given as 2 centimeters. So you will write it as 0.02 meters. Torque is given as 8 root 3 Newton meter. Calculate the magnitude of dipole. For dipole, we have PE sine theta. From here, you can calculate the dipole moment. For charge, see, electric field is there, dipole is there, length is there. Dipole is equal to charge into the length. From here, you can calculate the charge. Potential energy is PE sine theta. Last part, you know, no? Yes, I think you must be having difficulty in this only because that is formula based. This you can write it down because the derivation also you must be knowing. This you can copy. Then again, this is from current, because these are from current electricity and I have to discuss current electricity. That time I'll be discussing. So it will be easier for you to relate. Okay, Shahid? So that time I'll discuss this. And one more student sent, Tarif had sent. Okay. This is from capacitance. This I'll discuss tomorrow. Current electricity. Okay. One question I'm discussing, Tarif, which is from electrostat, electric charges and field. See, this says that 4-point charges are placed at the corners of a square. This, all of you, let me just draw it properly. It's a square given. This is saying this is 2 microcoulomb. B is minus 5 microcoulomb. C is 2 microcoulomb. This is minus 5 microcoulomb. These are located at the square. It's a square. So this is 10 centimeters. This is 10 centimeters. 10 centimeters. 10 centimeters. What is the force on a charge of 1 microcoulomb placed at the center of sphere? Not sphere, it means the center of a square only. Tarif, that is a misprint in your question. This is talking about a square. So it won't be a sphere. Sphere won't come. This is a square. So here 1 microcoulomb is there. Look, Coulomb's law we have studied. This is positive, right? So 1 coulomb due to this is positive, this is positive. So it will be moving like this. Again, look, what will be the magnitude? K, Q1, that is 1 microcoulomb, Q2, that is 2 microcoulomb, divided by, let's say the separation is x by x square. Clear, Tarif, this part? This is the force due to this. Is this clear? Then only the rest of it
Yes,
you'll
Miss
be able
clear.
to understand. Answer is very easy for this. No need to solve it. At least this much part you'll be able to do yourself. Tarif, this is clear? At least this much what I've written, Tarif.
Yes, Miss clear.
Okay. Now see, K, Q1, Q2 by X is just this separation that I have assumed. Now look, for the second charge plus 2, this will be also pushing this charge towards here. What will be? This is third, no? 1, 2, 3, 4. Yeah, so the third one. K, Q is 1 microcoulomb. This is 2 microcoulomb divided by x square. Can you notice one thing? Both the forces are cancelling each other. So F1 plus F3, the net is 0. They have cancelled each other because both the forces exerted are same. They are not letting 1 microcoulomb move. It is in equilibrium because of this. Coming to this. Now come to minus 5. Minus 5 will be attracting it. So it will be moving towards minus 5. This will be attracting it. Why? Because positive and negative. So F2, K minus 5 microcoulomb, KQ1, Q2 by again x square. And this will be moving towards it because this is again negative. So F4, this will be K minus 5 microcoulomb, 1 microcoulomb by x square, right? F2, F4. So both are also equal. Again, F2 plus F4 will also be 0. It means the net resultant force will be 0. Why? Because they will also be cancelling each other. Clear, Tarif, now?
Yes, Miss clear.
Okay. Rest of the questions, since they are from the current electricity and potential only, I'll be discussing after discussing some questions tomorrow.